In this tutorial, we'll compare rates of change from linear functions in different formats, such as tables, graphs, and equations. Let's take a look at our first example. The question states which of these linear functions has the biggest rate of change. Function A is written as an equation, and function B is written as a table. Another way that they could state this question is, which one has the greater rate of change? So let's take a look at function A. This equation is written in something called slope-intercept form. And that means that the y is by itself. And when the y is isolated, that means that the coefficient of x is the slope, and the constant is the y-intercept. So since slope is another word for rate of change, then we can clearly see that the slope, or the rate of change, is the coefficient of x. That's the number in the m position. So the rate of change for function A is 3. Now let's take a look at function B. To find the rate of change from a table, you need to use two ordered pairs. And you can choose any 2 points from the table that you like. So let's say we're going to use the first 2 points. In order to find the rate of change, we're going to use this formula, known as the slope formula. In this formula, we're going to substitute our y2 and y1 values in the numerator, and our x2 and our x1 values in the denominator, like this. y2 minus y1 is -4, and x2 minus x1 is 2. When I simplify this fraction, I get a rate of change of -2. Now, I can compare our two answers. The function with the greater rate of change is function A, because 3 is higher than -2. So function A has the greater rate of change. Let's take a look at another example. This one is asking you, which one of these linear functions has a lesser value? Another way of saying that is, which one has the smaller rate of change? This time, function A is shown as a graph. When we calculate the rate of change from a graph, we draw these slope triangles to calculate the rise and the run, also known as the change along the y-axis and the change along the x-axis. You can use any 2 points on the graph. They don't even need to be consecutive. This can also be calculated as the rate of change, and it will be the same as this distance here, because 4 over 2 is the same as 2 over 1. So again, when you have a graph, you calculate the rate of change by finding the rise, or the delta y, over the run, the delta x. So for us, this graph has a rate of change of 2. Now let's take a look at function B. Function B is a bunch of ordered pairs. This can also be organized as a table, just like in the last problem. Simply put your ordered pairs together in the same row, like this. Then choose any 2 points you like, and calculate the rate of change using this formula. Again, you can choose any 2 points from your list. Let's choose the first 2. Y minus y over x minus x. And you might be thinking, well, isn't this y2? Well, it depends. It depends on how you labeled it. If you labeled this one x1 and y1, and this one x2 and y2, then your formula would look like this. So it doesn't matter what you label them as long as you're consistent with the formula. So for us, this will give us a rate of change of 5 over -1 or -5. Now let's compare our two rates of change. Function A has a rate of change of 2. Function B has a rate of change of -5. So that means that function B has the lesser or smaller rate of change. For this next question, what if they gave you an equation that wasn't in slope-intercept form? that didn't have a y all by itself. Right now, this equation is in standard form. And when a sentence is in standard form, it means that the x and the y are on the same side. Sometimes they have a plus sign, and sometimes they have a minus sign here. It doesn't matter. As long as the x and its coefficient and the y and its coefficient are on the same side, then this is called standard form. To manipulate this so that it's in slope-intercept form, we need to use some inverse operations. Let's take a look at how we would rearrange this problem. The first thing we do is we'd get rid of this 2x by using an inverse operation of subtraction. Once we do that, we rewrite what we have. We have a negative 3y still on the left side, but now we have a 5 and a minus 2x on the right. It does not matter which order you write this. You could write it 5 minus 2x, or you could write it negative 2x and positive 5. It doesn't matter because the final step will still be the same. Dividing by this coefficient gives us the sentence y equals 2/3 x, because two negatives when divided make a positive, and then minus 5/3. It sure does look messy, but if we're comparing rates of change, that's the only number we need to look at. That concludes our lesson on comparing rates of change.